Hello, 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 hello. Welcome back. Is it just me or the days are like really moving by very fast? I'm not sure. Let's see what we have here. It's Friday, Friday, Friday. Oh, okay. I feel a bit relaxed today. I'm not sure, and we have some interesting things going on today. And I would like to share some knowledge. Okay. First of all, this question here. I'm not solving this today. I'm just going to go over some old questions I have solved before. I discovered LeetCode has this top 150 list, which is here, this one. And as I was scrolling through this, I saw a question I had attempted, and well, as you can guess, I did not solve the question. And this was last year. Valid anagram. Valid anagram. And now it surprises me to see that this question is actually very easy. So, guys, this is the importance of studying. Studying. I know I'm speaking to myself right now. Nobody is here. I think there are a couple of people. Okay, there's one person just joined the stream. Nice, nice, nice. But anyways, studying, repeating, revising the same thing over and over again is very, very important, right? And this is just a note to self, a note to myself. I'm really saying this. I'm really saying this because you know I solve problems, I solve some questions, and that's it. I don't even come back to them again, which is really bad. So the best thing to do is to solve at least the same question, maybe 10 times. Yes, with, I'm not saying 10 times in a row, but like, let's say you solve the question today, then you have to attempt it maybe tomorrow, right? And then the day after tomorrow. Then you give like 2 days space in between to see if you will still be able to solve the question on the fifth day, right? And then you do it again the following week, then a month or a week after, 2 weeks after, until that question sticks. The patterns are beginning to, play in your head. You begin to recognize the pattern to solve this question. That is going to be my way of doing things henceforth. So I can solve a question today, right? Tomorrow I'll repeat this question. But the day after tomorrow, I might not solve that same question again. I'll just give it some space and see if I'll be able to solve it on the fourth day. Then next week again, I'll repeat the same question. Because there are a lot of questions I know for sure I'll struggle to solve them again if I, encounter the same questions, because just because I did not repeat these questions, right? I solved this question, you know, it took me hours to figure the solution out, but then it will still take me hours to figure the solution out if I don't, practice it, if I don't solve it and try to uh, memorize the patterns, right? This might sound a bit controversial, but I think memorizing is really good, right? Memorizing is key to everything, especially when it comes to data structures and algorithms. Because there are some questions, right? If you don't, I know for sure, as a beginner, if you don't look at the answer, you will not be able to solve it. So after looking at the answer, right, you still need to practice it. You still need to delve deeper to, understand exactly what is going on under the hood, right? And, you know, so that's going to be my way forward. All the questions I've solved before, I will attempt them at least three to four times before completely getting comfortable with the question, right? Um. Okay, so let's see. What do we have to do now? Valid anagram. This is a very I'm so shocked now that I can actually solve this question. Wow, a couple of months back, right? Last year in December, I couldn't even solve it. It was just I attempted solving this question so much that I began to, and it's an easy question, right? So this is a testament. This is a proof of practice, right? Trying your best to you know do something and attempting to become better, basically. So here's a valid anagram question, and I just look at this. You can see in November 2023 I tried solving this question, and basically most of my solutions did not work. I didn't even continue solving it, right? And looking back at this, and I read the question again to see how I'll solve this. And it turns out it's really simple, right? But I'm not going to, you know, um call myself. Uh, I'm not going to say I was stupid. It's just growth, right? It means that I have actually, you know, grown from who I was maybe a year back, right? I'm not saying I'm the best at lead code. I mean, there are still some easy questions I might struggle with, right? And some medium questions that I certainly know for sure that I can't. But this is just to show every other person struggling at this phase that it's normal, right? It's normal as long as you're consistent in trying to become better, right? Things will improve, things will change, everything will become, I would say, fair, right? As time goes on. So let's take a look at this question and see how we can solve this. So given two strings S and T, return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a word or phrase, typically using the original letters exactly once. So, how can we solve this question? It, it's I hate to say that right now I know exactly what to do to solve this question. Even after reading this, right, I I can just visualize the answer in my head. Now, this is not because I'm some lit code genius. No, I am not. I am not at all. But because I've been solving questions, right? Just because of that, I've been solving lit code questions, and I know for sure that this question is not. I can recognize some patterns, right? And you know, to prove that, if I look at the similar questions here, I can see that there are some questions here I've solved before, right? Okay, this one is locked, but anyways, the point is I will be able to solve this question today. I hope so. So let's see what we can do. So we are given two words, S and T, right? And we want to, show if S is an anagram of T or if T is an anagram of S. If T is an anagram of S, so T will be an anagram of S if every letter in T, right, is used exactly the same amount of time in S. So basically, the words are the same, but the letters in the words are arranged in different positions. So you can see in S we have anagram, and in T we have naragram. Now, how do we prove this is exactly the same thing, right? So I will just take this. I think there is a question in the chat right now, but I'll get back to that. Let me quickly open my board. Let me duplicate this. Duplicate. I will answer every question. Today is Friday, so we'll have at least an hour or two today. So um, let's let's go. Let's go. Let's go. Let's go. Okay, so here is my board. I will erase everything here. This is a Q question that I solved yesterday. So I'll go over this question once again, right? So this will be so good for everybody, and it will help people a lot to also study in, if this works for you. I mean, you can use this method to study. But anyways, it's good to repeat the questions that you solved the day prior. Okay, so or the previous day. Somebody said, since when do you program? I'm guessing you're asking since when I started programming. 2021. Yes, 20. So about mid 2021. So let's say close to 3 years now. Yes. All right. Okay, so let's see how we can solve this anagram question. Now, an anagram is again um, the same word. I'll not say the same word, but two words formed differently by using the same letters, right? So we have anagram and naragram. So the letters in anagram are exactly the same in naragram. Nagaram. So how do we prove this is a valid anagram, right? How do we prove if T is an anagram of S, right? That's what we're asked. So say return true if T is an anagram of S. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using the original letters exactly once. Okay, so let's see how we can solve this. We have S and T, and we want to prove that that T is an anagram of S. Now, when we look at this, right? Sorry, I think there's a mistake somewhere here. Let me properly. I hope I'm not. Okay, yes. All right, this is good. Let me arrange this here. Now, when you look at, so one thing I've learned so far is that when we want to compare two words, right, to prove that they are exactly the same, it's typically um relating to the letters that that word is formed with, right? Knowing how those letters are arranged and how many of those letters appear exactly in both words, right? So we want to find out if this T here is an anagram of S. So how do we do that? Well, this is a frequency related question, right? So we need to count how many times each letter appears in both words, right? And if those letters are exactly the same, the count of those letters, or in other words, the frequency of those letters are the same, then it means the word T here is an anagram of the word S, right? So let's say T is the word we are going to compare against S, right? So let's count every letter in T. So I'll create a map. Typically, that's what we'll do at the end of the day. So we'll write N here. Now, how many times did N appear in this word here, Nagaram. So we have n once, and we don't have any more n, so we'll put n here. The frequency of n is 1, and we'll do the same thing for a. So we have 1, 2, 3 a's. So we'll put a 3. Then we'll have g. G is 1. Okay, so we have 1. I'll call this T map, right? T map. And we'll do the same thing here. So we can say this. We are looking for the next word. The next word here is R, right? So R here. R will be 1. We only have 1 R. We've already counted all the A's. And the next one will be M. M is also 1. Now, we are not really concerned about how the position of each letters. We just simply want to prove that the word T, right, is exactly the same as was formed by using every letter in S. That's all we need to do. So we'll check for S map, right? We can create a map for S as well, right? So we'll say I'll use a different color for the S. Let's use a blue color. So S map is going to be, we have 1. So we start with the A, right? So how many A's do we have here? We have 1, 2, 3 A's. So this is going to be 3. We have for N here is going to be 1. So N is 1. The next letter is A. We've seen A. So G, we look at G and we say G is 1. G is 1. R is also 1. And we've seen A before, so we have M. M is also 1. So now we've mapped both words, and we know the frequency of every character or every letter in each word, right? Now, all we need to do now is to compare, right? We need to compare, we need to compare both words, right? We need to see the frequency of each character between them. And first of all, we need to also make sure, right, that both words, before we get, let me just go ahead and compare the frequency of each character in the word, right? And then we'll come back to the edge cases later on. So here's what we need to do. Sorry, my time has been okay. Let's just leave it. So all we need to do now is to compare the frequency of each character. So we look at T, right? So we start with N. Now, how many times is N in T? The frequency of N is 1, right? So N has to be in S. First of all, the condition for a word to be an anagram of another word is such that every letter that word is made up of is also in the corresponding word, and also the letter has to appear exactly the same amount of time in the corresponding word, right? So in other words, if T has N has to be in S, that's 1, and also N has to have exactly the same amount. Yes, T of N has to be exactly the same amount of T of S. So N has to appear in S and the same amount of time. The frequency of N has to be also the same in S. So in this case, N is 1, right? So we have 1 N in T, right? Our string T has just 1 N. So we have to check if our S, right, also has N, and how many N does it have, right? So S has N, which is this, and we also have N here. So how many N's does S have? S has 1 N, and T also has 1 N. So for the character or the letter N, the conditions are respected or valid. So there is no violation there. So we'll move on to the next character. So the next character is A. So we also check again if A is in S and how many times is it in S. So A is also here, right? Which is true. So again, we have to compare. So we have 3 A's here and also 3 A's here. So for the letter A, the conditions are also respected or valid. So we'll move on to the next letter, which is G. So we'll check in okay, let me just cancel them out after checking. Hold on. We'll say we've checked for A, we've checked for N, right? We'll cancel them out. Okay, let's cancel. So we have G here, right? The next letter to look at is G. So is G in S, right? Is G in our S map? So yes, we have G here as well. So there's G and G here. Now, how many times does G appear in S, right? G appears once in T, and it has to appear exactly the same amount of time in S to be a valid anagram. Yes, anagram. So we have G also once in S. So we'll move on to the next letter, which is R. R is 1 here, and R is also 1 here, which is good. M is 1 and M is also 1 here. So this means that this word here is this word T. T is an anagram of S, right? T is an anagram of S. How do I do this? I'll say T is an anagram of S, right? So that's all we need to do. We will have to iterate and find out if every character in T appears in S, and the amount of time, the frequency of that character in T has to be exactly the same as the frequency of the character in S. And you know, that's how we'll be able to find out if the word is indeed a valid anagram. So let's go ahead and code this out. We can come here and I'll create, so valid anagram will be in arrays, right? So arrays and strings. What number is this question? This question will be number 242, right? So I'll create a file called new file. I'll call this leads dash 242 and I'll call this valid anagram. Okay, so I've created the file now. Now what we need to do now is to write out the code with respect to the explanation I made on this page here. Okay, I think I have one more question to answer before I start coding. So let's see. I'm learning DSA in Java. I know the core Java concept. My plan is to learn DSA, learn advanced Java concept, and blah blah blah. Okay, so we have start doing projects. Can you give me some advice on my roadmap? Okay. So you want to learn DSA. You know some Java concepts. Have you been coding in Java? Have you been actively coding in Java? Because practice makes perfect. At least I would not say practice makes perfect, but practicing builds some confidence in you, right? So my plan is to learn DSA. You want to learn data structure and advanced Java concepts. I don't think learning something in terms of programming, right? It's only when you did something that you actually go ahead and learn it. A lot of people, like myself, I know Python, right? I would say I know Python, but I can't say what does advanced really mean, right? Advanced is really, I'll say, subjective, because when you say something is advanced, I mean you know the basics, right? But the basics can also be seen as advanced stuff. Somebody who doesn't know how to program compared to somebody who knows the basis of a certain language, is really an advanced stuff, right? In that, when you compare it in that on that level. So what I'll say is just learn the basics and start solving easy lead code questions. Build the project you want to build. And I'm sure when you start building your project, you will encounter some difficulties. Then you can go ahead and search on YouTube and search on Google to see how to resolve your issue. That is the way I think you can study and study better. So there is not, at least in my own case, I don't think there's anything as advanced concepts unless you actually need that stuff, right? And you don't understand what it is or how to use it, then you can see it as an advanced stuff. But at the end of the day, once you understand it, it becomes basic, right? So there is, okay, advanced concurrency, multi-threading, and generics. You see, you don't just know all these things and put your hands down. You know them to use them in a particular context, right? So if you don't encounter the need to use certain things, then there is no need for knowing it because you will forget at the end of the day. So if you know it, then you must have a use for it. You must know why you should use it. I learned OOP because I want to use classes, right? I want to know how to create instances of classes. Because of my OOP knowledge, I can easily copy, you know, I can easily copy the the uh the code in Leeds code, right? So let's say this is, let me reset this back to what it was. So here you can see you have a class and you have a function in it. If you did not know about OOP, you won't be able to use this function, right? Or you'll be able to use this boilerplate code. It will look somehow to you, and you will not be like, oh, how can I use this? Oh, okay, this, I mean, I only know about functions. Why do I have class? What is class here? Then you go ahead and learn about classes. Now you know what classes are. You begin to use classes. You begin to know that, okay, I can create instances of my class. I can, use methods in the class. I can use properties of the class, right? So really, in my own opinion, that's how you learn how to program, right? So when you have a need for something, you go ahead and learn it and you use it, and you use it again when you encounter that same need, right? So this is a shift of mindset that I recently developed, right? There's no need, okay, you want to learn Python. Okay, you can understand the concurrency model behind Python. You want to understand multi-threading, um, you know, generics. Those are stuff that you learn, you just read and move on, right? But then when you encounter the need for it, you go back again and learn them, right? And try to understand them again. So that is how I have been studying programming, and I will not say it is the perfect way, but it is the way that works for me, and gives me um a faster pace into doing things, right? So again, there is room for improvement. We are all studying every day, so there is no perfect answer to, okay, this is how you have to do certain things, right? But I believe if you don't need something, there is no point knowing it, right? Okay, so um let's see. I'll paste this here. Okay, so I need to copy this part of my solution. Um Here you go. So again, I want to solve the anagram question, right? And we need to, first of all, like I said, we need to count every character, the frequency of every character in each word. So we can do that easily by using the counter method in the collection module. So we can say I think it's the counter class. Yes, the counter class in the collection module. So I'll say count S, right? So I want to count every word in Excel. I can use this. You know what? Let me show you how the counter works for those who were not here. The previous days. I can still go over this for you. Don't worry. Let's see. So let's say I want to count every word in a particular string, right? So I can say, let me copy this word here. So this is anagram. Oh yeah. So I can do this instead of creating my own function to do this, right? There's an easier or shortcut we can use in Python, right? So um we'll say n, or I'll say count letters, or I'll count characters, right? I'll call this count characters, and I'll set this to the counter class, right? Now this counter class is, so I'll import it from the collections module. So I'll say from collections import counter, right? From collections import counter. So I can put in here the word that I want to count, right? And let's print this and see what we'll have. So we'll say print count characters, and you'll see we'll have a count of every character. Now you can see we have A 3 times, N once, G 1, R 1, and so on, right? So with this, we've counted every character in the word, in the anagram word. So otherwise, we would have to code this out and write the functions to do this. So we'll have to create an empty dictionary, right? And then set the value into that dictionary and start counting that value every time, right? I'm not sure if I should show you how it is done, but you know what? For the sake of learning, right? Let's see what is happening here. So I'll do this. I'll comment this one out. You know what? Let me just leave it there. So I'll create a. Oh, you're welcome. You're welcome. Atomic God, you're welcome. So let's see what we can do here. So I can say, I'll call this my counter, right? My counter, and I'll set this to um an empty dictionary, right? This is an empty dictionary. So I want to count every word. So I'll define a function. I'll call this define. I'll say define create create um create count. You know what? There is no need for me to create a function. Let me just iterate through the word. I have anagram, right? I'll call this. I'll say this is my word, and I want to count every character in this word. Sorry. Okay, so let's say we want to do for character in word, right? Now if character, if the my counter has the character, my counter at character, right? At character, then I can just say my counter at this character, right? I'll just increment the count plus equal 1. Otherwise, else I'll just set this to equal to 1, right? And this is how we'll count every value in the the occurrence or the frequency of every letter in a word. So let's print out this my counter and see what is inside. So Q error. So there's an error here. What's the error? So here we are setting this if okay, so here's the error. So if character in my counter, right, then we can do this. Okay, so the error is gone. Let's see what we have now. You can see we have A3, N1, and so on, right? You can even do this. You can even try to, create your own class, right? You can create your own counter class and then create some functions inside the class to do all of this for you, right? But anyways, this is what the counter is doing behind the hood, right? Or behind the scenes in the background, right? So, oh, there's somebody else. Hi, Comfort. So, let's go ahead and count every character in the string. So we'll use this. We'll use the counter. Now, instead of writing all of this, we can just, instead of writing all of this here, I mean, this is not a lot of code, but this will simply, you know, it will be easier for us to just go with the counter class, right, from the collections module. So we'll say counter, we'll count the S, right? So we'll import this class. Let me just import this here. Import this collections, yeah. So we'll then count count T, the words in T, right? Count T, and then we'll say counter at T as well, right? Okay. Now we have both the map of both words. Now we will begin to compare the values. We will begin to check if the value, a particular letter in either word is in the other one, and also the frequency of that word is the same in the frequency of that character is the same in both words, right? So write a loop. So for character, I say for character in S. Sorry, in so we are comparing counter of the word T. We want to find out if T is an anagram of S. So let's start with T. So we'll say if count T, right? So we'll say for every character in the T, we have to say if first of all, if the word is not in the other count. So if we can say if character not in character of S, sorry, count of S, or if the frequency of that character, if so, you know what? Let me just do this. We can even directly get the count right from this. So we can say character. We can say key value per so key value. So character and count. I'll just put character and count, and I set uh this dot items. We can get this here. So we can say if the count is not if count if not or not count is exactly the same as count of S, right? Count S at this character, then we'll return false. Then we'll return false, right? We'll return false. So meaning if this condition is not true, right? If the character is not in the count S, and also if the frequency of that character is not the same as the character in S, then we just return false and we end the iteration there. Otherwise, it means we have found the character. I mean, we can prove now that this is exactly a valid panido, so we can just say return true. Now, there's a problem with this. This will work for now. This will work, but there's still a very small issue with this that we need to correct. So I'll copy this, and for the sake of this question, I'll just paste this here and run this, right? Let's run this and see. Now you can see this works for these two test cases, anagram and case 2, which is rat and car, right? The reason why this worked is because, now look at this. We have let's say S. Okay, so the constraint here is that the length of the S word and T words will be less, or I mean, will be superior or equal to 1 and less or equal to 5. Is this so this will be 50,000. Yes, so 50,000. Okay, so I mean, this is good. So there is a follow up. What if the input contains Unicode character? Would you adapt to the solution? How would your solution adapt to such case? Uh, anyways, let's see. So I mean, if it contains Unicode character, we've already counted the frequency of every character in the string, so there is no problem with that. Um, but in this case, what if T has a longer length, right? It means if we had, let's say, anagram, and let's say T has an extra word here. I'll just erase this. Let's say this is going to be anagram. Let me put a Y here. Anagrami or nagarami. Right? In this case, we would have counted the frequency of every character in the string, but then there will be one more character left that we did not count. And with our current solution, right, this would have been a valid, anagram. T would have been a valid anagram of S because, um, because the characters in S, right, are exactly the same, have the same frequency of against the character in T. Or okay, in this case, this will not work. But let's say it was S that had more words, right? More letters than T. So let me put S anagram like this, and say S had one more letter, right? One more letter, which is Y, and Y is equal to, let's see, Y here. We had Y here, and Y is 1, right? The frequency of Y is 1. But with our current solution, this will still work. Our current solution will still say T is an anagram of S. Meanwhile, as we are looking at this is not true, right? T is not an anagram of S, just because all the characters in S and T do not have the same frequency, right? So meaning we need to also check, right, for every word in S, if S is also an anagram of T, right? It has to be vice versa. It can't be in only one direction. You know what? Let's test this out and see. I'll copy some of the test cases here. So we have S and T here like this. I'll copy it and come here. So let's create an instance of our solution. I'll say this is solution class instantiated. So we'll say print. Let's paste anagram in this word here. So we have these, and this will be equal to, let's say, print solution dot anagram. So we'll say is anagram. So we'll put in which one was inserted first. I think S before T. So we have S here and T. So S goes in, S and T, right? So here's what we have. When we run this code, we'll get true, right? Because T is an anagram of S. So let's read this. Like I can see, it's true. But imagine now we're using T, right, to compare against S. Imagine we had Y here, right? And we run this again. This is still true. But looking at this is wrong, right? This T cannot be an anagram of S if T does not contain all the characters that S has, right? It is impossible. So we also need to check if S is also an anagram of T, and then we can return true if it is. Otherwise, we return false, right? So we can say Now this works for t, so what I'll do here is simply duplicating this code. So I'll Control D. Okay, you know what? This doesn't work. So I can just copy this and say, so instead of counting for t, now we are counting for s. And if every character of s is in t, and also if every letter of t appears the same time in s. So now this solution now will return false, right? Because you know this is not correct, right? So that's exactly what we needed to do, and to avoid cases where there are extra words and the words are not totally or entirely the same. The time complexity for this solution is not is so we are checking for every character in the count of t. So this is going to be a O of n. This is another O of n time complexity, right? So two O of n's, right? I can say it's O of n times O of m, right? N times n. Well, it's I would say you know what? Let's run this and see. Now there's room for improvement, and I'll show you how we can improve this. There's even a shorter way we can do this. I just realized that, but let me paste this part of the code. I don't want to submit this directly because I will remove this part because we don't need to return true here. We have to return true at the end, so we can put this here. Okay, I did copy this well, so I can do this. Yeah, so here's what we have. Let's run this and see. Da, 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 da. So the test cases have passed, but let's submit this and see what we have. Now you can see okay, oh, I'm solving this in lit code top the same, which is okay, fine. I did not know I was inside this part. But anyways, you can see the solution works, right? It works. It's actually fast, and 76.66. Sorry, that was funny. Anyways, but I'm not really you know I'm not very typical about this time complexity ranking and so on, but as long as the solution works and it is quite above 20%, to me it's not too bad, right? The measurement of the runtime, I'm not sure if it's the programming language you're using is also a factor that plays into how fast um, Let's Code ranks this question or rates the question, your solution. But yeah, I think this is actually fair. So let's see, another way we can do this, right, is to directly so when we compare, let me show you something. If we have two objects, right, I'll delete all of this. If we have two objects, I'll call this obj1, obj1, and say this, okay, two dictionaries. I'll say this is an empty dictionary, and obj2 is also an empty dictionary. If I said return print obj1 is exactly equal to obj2, right? What do you think will happen? This will be true, right? This will be true. So we can compare two objects directly or two dictionaries directly to see, if they are actually true. And the same thing will work in this case of this anagram case. So we can do this. We can say, instead of writing two loops, you know what? Let me push this first. That's solution one. So I'll say git add git commit dash m solution, come on, solution one. Okay, I usually do so. This array question lit dash 242 and I'll put and solution one like this. Okay, so now we want to, let's say we are trying to, we compare the objects directly, right? So we've created two objects, so I'll comment this out. We can simply do this, right? This is a shorthand version of what we just did here. We can say return count s, count s is exactly equal to count t, right? So let's run this and see. Now you can see this is false because we have anagram. So let's say we run this again. Now you can see this is true. So let's use this instead. So we can also submit this on LeetCode and see what the type complexity for this will be. So return. Now I think object comparison happens the same way we did this, right? So let's see. Yeah, the type complexity for this is going to be constant, right? So let's submit this. I keep solving this question here. I'll subscribe later. Now you can see this is much faster than what I did before. I'm not going to say one of the solutions is better than the other, but it's just that there's less code in some parts, right? So again, this is a testament to you know, repetition, studying, and showing up every day, consistency, right? As you can see, I attempted solving this easy question more than 5 times, right? And all my answers were wrong. Let me see what I did before. So I said if the length of s is not okay, this is true, right? Okay, that's good. Now for I in range length of t minus 1, right? If t at I is not in s, return false, s return true. Okay, so why is this solution wrong? Well, I'm just saying. Now you see, the problem with this is that I'm only checking if a character at t, right, if it's not in s, return false. Okay, but what if t, okay, t and s has, if the length of this is not the same as that, so it return false. Let's see what's wrong here. T at I will be every character in T, right? So for every character in T, if the character is not in S, then return false. Okay, but what if the character is already in S and we've seen it before, right? Why did this solution not work? Why did this not work? This would have worked for simple test cases. Oh, I see what's wrong here. Is it about the Unicode characters? I'm not sure. Let's see why this did not work. Okay, so we're saying yes, they have the same characters, T and B. So I'm returning true. Huh. That's interesting. How this would have worked, right? This solution would have worked. Wait, why is it true? The lengths are the same. So for every character in this, right, and I'm returning true. That's wild. Oh my god. Let's see what was wrong here. I mean, for the first character, this would have just returned false, right? This should have just returned false. Okay, I'm iterating through the string. Oh, I see. The iteration did not happen. The iteration did not happen. Okay, okay. So the iteration did not happen for me to even return false. Well, well. Because if you do length of this minus 1, right? Why am I doing length of this minus 1 in the first place? That's wrong. Hey, there's nothing like that. Remove this. Yes. So this should work now, I think. It should work. Aha. So now we have another wrong answer. I just say A. This is S. Ah, I see why it is wrong. So I'm directly saying if this is in S, right, return true. Meanwhile, right, this could be S, but S could have had it more than once, right? Which is why this solution here is wrong. So I see why it is wrong now. So I'm not really checking for the frequency. I'm just checking for the presence of that item in the corresponding string that we want to check if it's a valid palindrome or not. So yes, this would have been wrong. Yes, I agree now. I agree. Um, I found redemption. I found redemption in my solution. Hello, Code Lively. Code Lively is here today. Uh, Welcome to the stream. Although you are late to the party. Anyways, let's continue with another question I've solved before, and this is not one of them. Okay, we are done with this. We are done. Let's close all of this. I'll go through the string. Eh, you know, I was thinking about sliding window today, and let's see some sliding window problem. Do 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 dun, 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 da 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 da. Linked list. C sorted. Where is this thing? Sliding window. Yep, sliding window is here. Okay, so there was this question I saw, this medium question. Longest substring without repeating characters. Oh my god. I I I count matters. Yeah. Okay, so let's see what we can do here. Let me refresh the chat and see if there are any questions. No questions, no questions, no questions. So I've solved this question before. Now I can't see the solution, but let me see if I still remember whatever explanation I gave then. So longest substring without repeating characters. Given a string S, find the length of the longest substring without repeating characters. Now a substring is simply a contiguous non-empty sequence of characters within a string. So how do we find the longest substring without repeating characters? There is this. I discovered something, and I remember very well. Speaking about this strategy, or should I call it a strategy or a trick? when it comes to sliding window problems. When you are given a sliding window problem, and first of all, you have to recognize if it's a sliding window problem or not. But usually when you when the question is asking about say substring, sub array, right? Sub list or sub array, there is a chance of a sliding window algorithm being used to solve this question. But then also there is a sub trick to sliding window problems. And I was so excited to share it the other day. But let's take a look. When we are given a sliding window problem, it's usually, you know, either we are increasing the window, or we are shrinking, or we are moving a particular set of uh, a particular size of window across the array in order for us to get our substring or sub array. So let's take a look at an example. Let's say I have an array. I'll call this word, right? Or let's say nums, and nums is going to be equal to I'll put, let me use a different color. I usually use the colored one to highlight something. So we'll use nums. Okay, I'll call this numbers. Numbers equal to um 1, 4, 6 to 8, right? And we are asked to find the maximum sum of two integers in this array, right? The maximum we can get in this array. So first of all, we want two integers, and we want those two integers such that we have the maximum sum in the array, right? Two integers, maximum sum. Now in this case, when you think about this, so let's say we're asked to find two integers, right? If we're going to use you know what, let's say, if instead of me saying two integers, I'll say let's find a sub array, right? A sub array of length or size 2 that has two items, obviously, and the sum of those items is the maximum we can possibly get within this nums array here, right? So here's what we need to do. First of all, we need to find two sub arrays, right? Two We need to find a sub array of a particular size. Now the size of our sub array, right, is going to be the size of our window, right? So there is no way we'll get more than 2 to actually solve this question. We want exactly two items or a sub array of size 2, such that the sum of those two items is the maximum we can get, and we have to return those arrays. I mean those items or those numbers, right? I think there's a question like that. Let me set through the sliding window problem. It should be, yes, sub array product less than k. This is another nice question, but there is maximum sub array sum, right? Anything sub array is sliding window. You can see most of the sliding window questions are sub array. I want There is a sub array question that I really want. Uh minimum, wait, I think it should be in the easy part. If it's not in the easy, then it should be a medium question with most. You know what? But the idea is, I think I solved the question like that before. Maximum sub array sum. There is something like that I did previously, which was it's in sliding window. So where is sliding window here? We have sliding window. Oh, sorry, I have a call. Just a minute, please. Sorry, that was um. I would call. You know what? No excuses. I just had to pick that call. Anyways, sorry. I need to finish quickly. Da 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 da. So does it to beneficiaries? Workies. Yes. Okay. Da da da. Okay. So I remember exactly where I stopped, so I'll still continue from there. I'm not going to say, oh, where did I stop? Okay, so I was explaining my tricks or the tricks I use to solve sliding window related problems. And I was going to look for a question that I solved previously, a sliding window related question. There's this, where's sliding window? This is array binary set, doubly linked this. Oh my god, doubly linked list. I only did it once and I totally, forgotten about it. Oh, matrix once. Wow. I need to go back to those. Yes. Maximum sub array sum. Maximum sub array sum. This is the question I was looking for. So, this is not a lit code question, but it's a question I read somewhere and I tried solving it here. But the idea is, I'm not sure if this is a lit code question or even if it's a lit code question. I don't remember the number of lit code question it is. I would usually put lit and the number to actually indicate what number of lit code question it is. But this time around, I didn't do this, so it's probably a question I saw somewhere else. Anyways, the this problem here, very interesting. But what happens is we have a fixed size of window, right? Usually, when we are asked to find something of a certain size, right? Let's say the maximum sub of a sub array with size 2, 3, 1, size k, if it's going to vary, right? It means our window has a fixed size, right? Meaning we have to shift the window across. So let me copy this. This is 1, 2. So this question is basically asking us to find the sum of three contiguous integers in that array, such that the maximum we can get, so that we can return the possible maximum, right? You know what? I can still use this. I can still use this one here. So let's say, where's my, yeah, let's continue with this. So we want an array of a sub array from this DOMS array here of size 2, which means we want two integers in that array, and we want to get the maximum possible of the maximum possible we can get in this array. So we want to choose two contiguous values, right? So our window will start from here to here, right? And then we'll keep shifting. So the next two sub array we can have, or the next sub array of size 2 that we can have, will be 4 to 6, and the next one will be 6, 6 to 2, and then 2 to 8, right? And we'll calculate the sum each time, right, to see if, or to see the maximum we can get. So here's what we need to do. When we start here, the first sub array we'll have will be 1 to 4, right? The second one will be 4 to 6. Third will be 6 to 2. And the fourth one we'll have will be 2 to 8, right? And we'll calculate the sum each time. So this will be 5. This will be 4 plus 6. This is 10. 10. This is 9. This is 10 again. So now we can conclude here that the maximum we can get here will be equal to 10, because this 10 is the maximum. So 10, right? Now, the point of this demonstration is to actually show that when we have a fixed size of item to find, or a fixed size of sub array or substring, right? Our window has to have a fixed point, or a fixed size, meaning we'll set two pointers, right? We'll have the beginning of the node of the window. I'll call this left and right. So we'll have the left and the right, and we'll shift them simultaneously, right? We'll shift them, and the size of our window will not change. So the both pointers will move like this. They'll move simultaneously. So we'll move to this point, right? And then we'll move from here to here, and then from here to here. So that's it. Where we have a fixed size of window to solve a sliding window problem, we set the window at a particular size, right? We set our pointers at a fixed point, and then we slide them across the window. But in the case where we are not given a fixed size, right, to a fixed size of sub array or substring, then we need to do something else. And what do we do in this case? We need to start our window very small, right, at a single point, and then increase the window as long as the condition is not violated. But when a condition is violated, we will shrink the window, right? We will move the window to a position where the condition is now valid for us to continue increasing the window, which is the case of this question. Let me remove this. This longest string without repeating characters, longest substring without repeating characters. So we are given A, B, C, blah blah blah, some string there. So here's our string. Here's our given string, right? Here's our given string, and we want to find out the longest substring without repeating characters. Now here is what I meant by the second case of sliding window. When we are not given a particular size of substring that we needed to return, then our window has to start very small. So we will start the window from this point, right? So far we want a substring without repeating characters. So we'll start here, right, and start increasing the window across. Now, so far we have A and B, so no repetition. so far. So we have unique values. We'll continue. We have ABC, still unique characters. And when we get to this point, right, we see A again. So meaning there is repetition. The condition has been violated. So what do? We need to shrink our window, right? We need to shrink our window and remove every possible duplicate. Remember, I usually say the sliding window has two ends, left and right. So this point here and this point here. Since there is a duplicate here, we need to shrink the window past the point of duplication so that we will not see any more duplicates in this case. So here is what we need to do. We need to shift this past the point where the duplicate happened, right? So our left will no longer be at this position, right? We will need to move the left past this place. So the left will then move from this point to this point here. So the left will move from here to, oh God, from here, come on. Okay, you know what? This is my fault. Thank you for participating. We'll need to move the left point, right? Since the duplicate happened here, we'll have to shrink our window, right? We have to shrink our window to this point. You know what? Let me just delete this. I'll just write it here. So the duplicate happened here, and the string we had so far would have been ABC, right? And then A happened again, so we have to remove A from the duplicates. So this will be our current string. So we'll move from here, from this point, right? We were here to this point, and then the duplicate happened here, right? So what we'll do then is to shift and start our new string from here all the way to here. And then when we reach here again, there is a duplicate. So we'll remove this from the string again, right? And our string will continue from here all the way to this point, right? And then we'll see a C again, which is another duplicate. So we'll remove C, right? We'll move our left point to this point, and our right pointer would have been at this point. So the current string at this time will be ABC again, and we'll continue shifting the right pointer, or the right position. I would not call it right pointer, but the right position will keep increasing across the string, right? As long as the current condition is true, and the condition is such that let the string that is formed between the left and right pointer have distinct characters, or the letters should not be duplicated. That is all, and we'll continue shifting the right point across the table, as long as there is no duplicate. If there is a duplicate, we'll shrink the window by moving the left position. We'll shrink the window like this. So how do we solve this question? Now I've gotten an idea of what to do. So here is how I'll solve this question. Even though I've solved this question, like, I think a couple of weeks back, right? Maybe in day 20 something, or I don't really remember. So let's see how we'll solve this question. Here's what I would do. I would say, first of all, we have a character, right? We want to keep distinct characters. So meaning the best way to keep distinct characters or distinct items without duplicates is to use a dictionary. I will always use a dictionary to find, distinct characters, or characters without duplicates, with avoiding duplicates and so on. So here's what I'll do. I'll say A. I'll create a dictionary. I'll call this A, right? A is equal. We'll count how many A's we have so far, right? It's not how many A's we have so far. We'll count the index at which A is, right? If we had duplicates, right, this will automatically detect it. It's not going to be based on the value of A, right, or the frequency of A. automatically, when you have two words and you insert them in a dictionary, the dictionary will remove the duplicates. So what we'll do is we'll keep the values, the words or the letters, sorry, we'll keep the letters and their corresponding index. So let's do that now. We'll say A, and the corresponding index of A here will be 0. Right? This is how I remember solving this question. Then we'll have B. B is at index 1. Now, the reason why we need to use this index is because we want to shift the left pointer, right? So let's say our left is here and our right also started at this point, right? Left and right will start at the same position. So we'll then move the left, right? So as to increase the window, the size of our window. So left will be here, right? And I mean, left will be here while right is here. And then right will move again to C. So right has to move to C. So we'll have C here. C will be at index 2, right? And then we find A again, right? In our map, we already have A, B, C, right? And A is already here. So since there is a duplicate and we are always adding the current character to the map, this will be removed, right? But how do we shrink our window in this case? Because we know when the condition is violated, the window has to shrink. So how do we shrink the window in this case? Well, we'll shrink the window by moving the left position, right? We have to move the left pointer to the next or past the point where the duplicate happened, or past the letter where the duplicate happened, right? And there is no way to do that other than knowing where we previously saw this current duplicated character. And how do we know that? We simply know it by the index at which we store the letter, right? So this letter is at index 0, so we have to move this letter past index 0, and by simply taking the position, right? So we'll say the left pointer will move, we'll take the value of this is 0, so we'll move it 0 plus 1, so left will be this. Now our current value or our current string will be BCA instead of ABC, right? ABC, so BCA. A here will be at index 3. This is our current string, B, C, and then A. So next thing we do is to increase our window, right? Because we don't have any duplicates yet. So when we increase this window, right, we'll move it to this point. Now you can see that there is another duplicate. So what do? We move it past the point of duplication, and we know this duplicate occurred at B, which is at index 1, right? Which is at index 1. So we'll move this left pointer forward to shrink the window. So this will move to this point, and then we'll have the value of B updated to whatever it is now, which is R here. So this will be equal to 4. So I'll change this to 4. Right? So we'll continue again. Right pointer moves to C. There is duplicate here. So we shrink the window. We update the value of C. C will be, in this case, will be 5. Now I'm just doing this. I've not answered the question yet. C will be 5, right? And the same thing will happen as we continue. But now this time around, look what happens here. We move the right pointer to this point. We have a B here, right? Do we move B past C? Of course, we have to do that, right? We have to move the left pointer past the point where B occurred, right? So we'll move it to this point here. Now, something interesting will happen again. So we have the left pointer, the right pointer will be at this position. Now there is a duplicate, but currently, right? Currently, if we move this left pointer past okay, the case will not work here. I was thinking about, where we had values and then, there were duplicates in the current window. But now moving the left pointer will be past the duplicates, right? But anyways, the normal way of counting and then shrinking the window will work, right? It will work in this case. So there is no s- complicated edge cases at this point. But let's say, you know, how do okay? So we know how to find the strings without duplicate at this point. But how do we calculate the size of that string? Because we want to return the maximum, right? The longest substring without repeating characters. So for us to calculate this, it's there's this way I do it normally. So I say the longest substring will be the distance between the left and the right position. That's all. So we reduce the left, we reduce the left from the right. So we say L, R minus L, right, will give us the size of our substring. And we want the maximum, right? We want the maximum size. So we can use the maximum function to find the current maximum size. And then we'll find out which one is the longest one, and we'll return the maximum at that point. Don't worry, I'll write the code for this before we close today. But let's say here. Now, if we do this, let's go back to the beginning where, the left and right pointer were at index 0, right? At this point, or let's say, yes, where they were here. So I'll put the left. I said the left and right will start at the same position, right? So we have left and right here. At this point, the current maximum or the current longest substring we have here is going to have just A in it. A in it like this. Now, the size of this substring would have been 1. But I said to calculate the size of the substring is the distance between the left and the right pointer, right? So if we did R minus L, we'll have 0 minus 0, which is 0. This is not correct. This is not the size of our current longest substring. Our current longest substring has a size of 1. So how do we calculate this instead? So instead of doing just L minus R minus L, we do R minus L plus 1, right? Now the reason why we do this plus 1 is simply because the left and right pointers start at index 0. They start counting from 0, right? So we need to, make sure that we are always counting in human counting form instead of the computer way, which is starting from 0. So we start from 1 if there exists a value in the string. And as we increase across, right, this calculation will work. So when we are here, right, R would have been 1, right? So if you do 1 minus 0, you get 1, but when you add 1 to it, we'll have 2. So our current longest substring will be AB, which is 2 letters in the string. That's size 2, right? So the current maximum we'll have at this point will be size 2. So this is how we'll solve this question. Now there will be some edge cases where increasing the left pointer will be strictly dependent on that. First of all, in the case where we have duplicates, I, I've forgotten how I did this, but you know what? Let's solve this question first and see whether I'll be able to solve this. So I'll come here. I'll write out the solution. Oh, it's 7. 7 already. 7 p.m. Do, 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 do. Where's my playground? Okay, so here's my playground, and I will solve this question here. So first of all, I need to count. I need to keep a dictionary of every character in the string, right? So I'll say um I'll call this character dict and set this to this. Now this is a map. I mean, some people call it a hash map, but I'll call it a map. I'm keeping a map of every character in the string. So now the next thing I need to do is to say, I'll call this maximum maximum sub string. For now, I'll set this to equal to 0, and I'll create my left pointer. Left will be at 0. Now I'll iterate through the string, add every value to this to the dictionary, and then also update the left pointer if some conditions are not met. So I'll say for I in range, the length of the string s, right? We want to add the character to the dictionary. So how do we do that? Well, first of all, we need to check. Um, I mean, to add the value, it's not hard. We'll just say character at dict, right? Character dict. Um, okay. Instead of calling this I'll call this right. This will be the right pointer, and right. So s at right. I'll just put s at right, which is the current value. We'll set this to be equal to right. Okay. Now, when we set this immediately like this, we might end up with cases where we are already updating the dictionary before checking if it already existed. And so let's say if so the condition is that if the current character at um so if the character is already in the dictionary, if s at right in dictionary, sorry, character dict, and you know what, let's come back to that. So if the character is already in the dictionary, we need to shift our left pointer past that point, right? So say left to be equal to um dict s at this point here. This will return the value, right? But then we have to do +1. Okay. Otherwise, we'll set the value here. Okay. If it's not in the dictionary, we'll set it in here, and we can say we can do this. We can say current max should be equal to the difference between so I'll say the maximum. Let's say here this is the distance or length of sub string will be r right minus left +1, and then we'll do the maximum between the previous maximum, which is max substring. So I'll change this to max substring because this is what we'll return at the end of the day. So max substring, difference between max substring, the previous one and the current one now. So this will be max substring and len of substring, right? So the maximum between these two will be set to the current maximum. This is good, right? I think at the end of the day we can return the max substring. All right. Now this will work, but I know very well. I remember very well there was something else to do, right? So let's see what it is. Bam, 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 bam. Let's use this string here, and I will just create an instance of the solution class. Solution is going to be solution, right? Like this, and let's say print solution dot length of substring here. Sorry about that. This should be 3, right? We have 3. Okay, that's good, but that's not enough. There is something else. I remember what it is. So if our current window has a duplicate, right, and the left pointer, the position of the left pointer is the left pointer has already moved past it, right? Or what was it? I'm forgetting what it is. There was an edge case that needed to be checked, you know. Because we can't keep moving the left pointer like this, right? We can't just keep moving the left pointer like this. Let's say we've seen a duplicate before, right? Let's say we are this. We are at this point. Oh, I can't remember. Wait, let me see my solution. I mean, my current solution works, but there's just one thing missing, which is something I really, understood. I was really serious about it. Exactly. So the current value has to be less or equal to the left pointer, right? The current value has to be less or equal to the left pointer. What does this mean? It means if duplicate is and last occurrence is less than we need to have in our current window we need to have unique values, right? And if our left pointer has already moved past. Wait. Oh, there's a way I did this. The left pointer is less or should be less or equal to the current index, right? Let's say, okay. Oh, wait. Let's say we are here, right? And we move this left pointer to this point. Okay. Our dictionary. The idea is that if our current window already has values that we've seen before, right? We can't shift. We can't. We are always doing this. I need to remember that. Let me create some string here. There is no way I'll forget this again. And this is a very, nice edge case to know. Because let's say we have A, B, C, and then we have we have B, and then A. Okay, so good. Let me put another C here, for example. Or let's say E, E, for it. Yeah. So again, we have our left and right pointer here. Left and right. Okay, they both start at the same position. We know that, but anyways, when they start here, our map will look like this. So we have a map A1, A0, sorry, A0. And then we'll move this to this point. Move here. B will be equal to 1. Then we see a C, right? C is here. C is equal to 2. Then we have a B again, right? So we can't add the B to this point, to this dictionary. So we move the B. So we move past the B, right? We move past the B here. Okay. Now the next time we go here, we see an A, but A is already in our dictionary, which is here. A is here. So what do we do in this case? Now remember very well, we always move past the point of duplication, right? One more than it. If we look at A here, the index at which A is 0, right? And 1 more than 0 will be at index 1, meaning we'll have to shift the left pointer back, right? This is not right. We can't do this. So we always need to keep, I remember, we always need to keep the left pointer to either be, for our word to be exactly, so in this case here, right, we will not shift the left pointer. We'll simply update the value, the position of A in our map, right? This will become maybe 4, right? This is 4, and we continue. We don't need to shift. We don't need to shrink the window at this point, because shrinking the window meaning we'll have to move left pointer back, which is wrong, because when we move the left pointer back, we have B in the window, we have C, and when we have B, so we have a lot of duplicates here. So we don't need to shift the pointers. I remember. We don't need to shift the pointers. So the only case where we have to shift the pointer is if the character is in the dictionary and the left pointer, right, is less or equal to, right, sorry, and this equal to this, right, then this will work. So let's run this. You can see we have 3. So I can submit this elite code now, and we will finish for the day. This is probably the longest I've streamed in a while. So let's see. Yeah, 1 hour 30 minutes. That's nice. So I run this. It worked. Submit. This worked as well. So 51%. Not bad. Good. I will solve this question again and again, maybe at least 10 times. All right. So I'll need to push this to GitHub. So let's say we have git add git commit revision sliding dash window lit dash 2 Wait, I solved a valid anagram question, right? Oh, yeah, lead slash two. I think it's question what? Question three. Lead three. I'll say, and we have strings, which is going to be valid dash, sorry, leads dash 242, right? Valid anagram, valid anagram. I've been doing this mistake all the time. I would like to be separating this with two here. So instead of that, so I'll know which one is the data structure in the question. So this will be two here. Strings, yeah. All right. Commit, good. Git add. Oh, I needed to put this here to show how much time I've revised this, right? Uh, you know what? I don't think there is a need for that. Is there? Let me see. You know what? Let's put it here. Arrays and string. No, cancel. Don't do it. I'll create a directory here. I'll call this repetition. Repetition here, and the repetition will contain the value. So this is lit dash 242 dash valid dash anagram, right? Oh, let me call this repetition 1. So I'll call this dash rep 1, rep 1, repetition 1. Okay, so I'll just say git add, git commit slash m. I'll just call this folder structure, folder slash structure. Okay, git push origin main. All right, thanks to everyone that has been here. It's lovely having you guys, and I can be thankful enough for you people studying with me, studying data structures and algorithm. It's the best feeling ever when you solve a question, right? Especially a medium question. I don't know how much flex a hard question will give me, but anyways, um, it's good. Thanks for tuning up, staying through this stream, and I'll see you guys tomorrow. Stay coding. Okay, that was. How do I